So this is exercise 1.1 from R D Sharma. So question number 3, right?
Yes.
Test whether the following relations R1, R2, R3 are reflexive, symmetric, and transitive. R1 on Q0 defined by A, comma B is belongs to R1 if and only if A equal to 1 by B. Okay. Q0 means Q minus 0 because here it is defined as A equal to 1 by B. This. So here B not equal to 0, and when B equal to 1 by A, also A not equal to 0 because 1 by 0 is undefined. So Q0 means Q minus 0. Okay, let A belongs to R1. A belongs to R1. How this possible? A is from the set. A belongs to Q0. A belongs to R1, not A belongs to A belongs to R1. It is not true because A is an element and it is from the set Q0. R1 is a relation. A relation is a ordered pair. So A not equal to 1 by A for A belongs to Q0. So R is not reflexive. So this is not this is not correct because if A equal to 1 by A, okay, so R if R1 is reflexive, then A comma A belongs to R1, and if A comma A belongs to R1, that means A equal to 1 by A. That means A square equal to 1, and A square equal to 1 means A equal to plus minus 1. That means not for all A belongs to Q0, A comma A belongs to R. That means it is not reflexive. So you have to give an example or like this. You have to write like this, that for A equal to plus minus 1, A comma A belongs to R1. So there is an element 2 belongs to Q0. Q0 for this 2 comma 2 does not belongs to R1. That means R1 is not reflexive. Let A belongs to R1. We can write okay, we can write A equal to, no, we this is not. Whenever you are assuming A comma B equal belongs to R1, that means what? The definition of R1 is A equal to 1 by B. That implies A equal to 1 by B, because whenever A comma B belongs to R1, that means A is related to B, and the definition of R1 is A equal to 1 by B. So A comma B belongs to R1 implies A equal to 1 by B. And from this, it is also implies that B equal to 1 by A, that implies B comma A belongs to R1. So R1 is symmetric. Okay. Now transitivity. A comma B belongs to R1 and B comma C belongs to R1. R, it is R1. That means this implies that A equal to 1 by B and B equal to 1 by C. So that implies A equal to 1 by 1 by C equal to C. So that implies A not equal to 1 by C. A comma C does not belongs to R1. So R1 is not transitive. Okay. Okay. So Question number 2, R2. R2 on Z defined by A comma B belongs to R2 if and only if A minus B mod is less than 5, equal to 5. Here also A belongs to R2. This is not correct. R2 is a relation and A belongs to, it should be, sorry, here it is, the set is Z. A belongs to Z. If A belongs to Z, then mod A minus A, that is equal to 0, which is less than 5. So that means, okay, here you have to write some more things. That is A for all A, for all A belongs to Z. After this line you have to write this, for all A belongs to Z, A comma A belongs to R2. That implies R is, and therefore R is reflexive. Okay?
Okay.
Let A comma B belongs to R2 and A minus B is mod A minus B is less than 5. Then mod A minus B minus A is also less than 5. Because A minus B mod is equal to B minus A. So here you can write this as mod of A minus B is equal to mod of B minus A. You have used this property of modulus function. So mention it. And you have to write this implies sign, because from this we can conclude this, and from this we can conclude this using this identity, and from this it is implies that B comma A belongs to R2 and hence R2 is symmetric. Transitivity, let 1 comma 3 belongs to R2 and 3 comma 7 belongs to R2, which is 2, and 3 7 mod is 4, which is less than 5, but 1 minus 7, that is not okay. 1 minus R2 is not transitive. Okay, right. Next, question number 3. Yesterday we have done, I have, did I correct question number, okay, question number 3. R3 on R real number is defined by A comma B belongs to R3 implies are implied by A square minus 4AB plus 3B square equal to 0. Okay. A square minus 4AB plus 3B square. Let A belongs to not R3, this is R. A square minus 4A plus 3A square. Okay, which is 0. So, okay, so for all A belongs to real number, for every real number A comma A belongs to R3, because A square minus 4A square plus 3A square, which is 0, and 0 belongs to 1 minute. Okay, and which is equal to 0, obviously. The equation was A square minus 4AB plus 3B square equal to 0. Okay, so this is equal to 0, that means R is reflexive. Then let AB belongs to R3 and A square minus 4AB plus B is 3B square equal to 0. Then just interchange the, so here B square minus 4AB plus 3A square is not equal to 0. How you can say this? Either if it is true, then you have to prove, and if it is false, then you have to give an counter example. So you have to find such A and B for which A comma B is equal belongs to R3, but B comma A does not belongs to R3. So think about an example, just like 1 comma 3. Okay, for transitivity you have chosen two elements, 1 comma 2 and 2 comma 3. So let us take this example. Let us take 1 comma 2. 1 comma 2. So 1 square minus 4 into 1 into 2 plus 3 into 2 square. 1 minus 8 plus 3 into 4, 12. Okay, let's take the opposite. 2 is 2 comma 1 satisfying? 2 square minus 4 into 2 plus 3 into 1 square. 4 plus 3 minus 8. It is not also satisfying. 2 comma 3. 2 square 4 minus 24 plus 3 into 9. It is also not satisfying. 9 minus 24 plus 3 into 2 square means 14. 4. 12 plus 9 minus 24. It is not also satisfying. Okay, try to solve this equation. A square minus 4ab plus 3b square equal to 0. A by b whole square minus 4a by b plus 3 equal to 0. So, okay. Okay, so a square minus 4ab plus 3b square. I'm solving this equation, okay. So b square common. So a by b whole square minus 4 into a by b plus 3. So this is, let us take a by b equal to x. Let x equal to a by b. So x square minus 4x plus 3 equal to 0. X square minus 3x minus x plus 3, that is equal to 0. That means x minus 3 and x minus 1. These two are factors. So a by b minus 3 equal to 0 and a by b equal to minus 1 equal to 0. Minus 1 equal to 0. So a by b equal to 3 and a by b equal to 1. So a equal to 3b and a equal to b. So one of the solution is a equal to b. That means a comma a, this type of elements belongs to R3, and ab are from the real numbers. So a comma a, from this solution a comma a is belongs to R3, and here a is equal to 3b So from this solution, this is clear that this relation is not symmetric, because if A is equal to 3B, that means 3B comma B, if this belongs to R3, then B comma 3B does not belongs to R3. So because first you have to square 3B square plus minus 4 into 3B into B plus 3B square. So this is 9B square plus 3B square and minus 12B square. This is equal to 0. So if you reverse this element, so that means what? B square minus, this is 12B, and this is plus 3 into 9B square, because in place of B we have 3B, right? This is what? B square minus 4AB plus 3A square, and it is A square minus 4AB plus 3B square, and A is equal to 3B. So this is 28B square and this is 12B square, not equal to 0 because B not equal to 0. If B equal to 0, then this element is 0 comma 0. That is obvious. Okay, so from here it is, I mean, clear that it is not symmetric. So the solution of this equation is A equal to 3B. That means we have to take here 3 comma 1. So this is, we have to take 3 comma 1. A should be 3B types. So this is 3 comma 1. This is belongs to R3, but 1 comma 3 does not belongs to R3. And for transitivity, these examples are not correct. How you take this? You haven't checked it. Have you checked? Oh, 1 minus 8 plus 6 equal to 0. I have already told you, don't hurry. So 3 comma 1, no, this example will not work. Okay, 9 comma 3, take 9 comma 3 and 3 comma 1. These two belongs to R3. Check 9 comma 3 or 3 comma 1 whether belongs to R3 or not. And for transitivity, 9 comma 1 should be belongs to R3, but 9 comma 1 does not belongs to R3 because but 9 comma 1 does not belongs to R3 because this 9 whole square minus 4 into 9 into 1 plus 3 into 1 square, which is 81 minus 36 plus 3, which is 84 minus 36. It is not equal to 0. So 9 comma 1 does not belongs to R3. So this is not reflexive relation. We have given an example, and also this is not transitive relation, and this is also not a symmetric relation, and we have given an counter example. That is 3 comma 1 belongs to R3, but 1 comma 3 does not belongs to R3. And for transitivity, this is the example. Next, problem number 4. Let A equal to 1 comma 2 comma 3. R1, let R1 equal to 1 comma 1 1 comma 3 3 comma 1 2 comma 2 2 comma 1 this 3 comma 3, and R2 equal to this and R3 equal to this. Find whether or not each of the relation R1 R2. Find whether or not each of the relations R1 R2 R3 on A is reflexive, symmetric or transitive. So okay, so for R1, 1 comma 1 is there and 2 comma 2 is there and 3 comma 3 is there. So for all element 1 2 3, the reflexive ones are in R1. So this is reflexive. R1 is reflexive and 1 comma 3 is there and 3 comma 1 is there. So this is okay. 2 comma 1 is there but 1 comma 2 is not present. So this is not symmetric. Reflexive but not symmetric. And 1 comma 3, 3 comma 1 and then 1 comma 1 is there, and 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 3 comma 1, 3 comma 3, 3 comma 3 and 3 comma 1, 3 comma 1 is there, but and 2 comma 2, 2 comma 1, then 2 comma 1 is there, and any other no. So this is transitive. So this is not symmetric, but this is reflexive and transitive. R2 is not reflexive because 2 comma 2 is there and other 1 comma 1 and 3 comma 3 is not present, so it is not reflexive. 3 comma 1 and 1 comma 3 is there and 2 comma 2 is there, so this is symmetric. And 3 comma 1, 1 comma 3 is there but 3 comma 3 is not there, so that is why it is not also not transitive. So this is symmetric only. Okay, so for R3, 1 comma 3 is there, 3 comma 3 is there, so 2 comma 2 and 1 comma 1 is not present in R3, so this is not reflexive. 1 comma 3 and 3 comma 3, it is not also symmetric because 1 comma 3 is there but 3 comma 1 is not there, so it is not reflexive, symmetric. And for transitiveness, 1 comma 3 is there and 3 comma 3 is there and 1 comma 3 is there, so it is transitive. So relation 3 R3 is transitive only, R2 is symmetric only, and R3 is reflexive and symmetric, reflexive and transitive only. So let us check what we have written. So this is R is reflexive. Okay. Here 2 comma 1 is in R1 but 1 comma 2 is not in R1. So this is not symmetric. 2 comma 1, 2 comma 1. Okay, 2 comma 1 and 1 comma 3 is in R1. Okay, so this is also not transitive. R2, it is not reflexive, it is symmetric, it is not transitive. It is 1 comma 1. Okay, 3 comma 3 is also not there, and 1 comma 1 also not there. Here, if you write 1 comma 3 and 3 comma 1, then which is acting as a mediator? 3. So it should be 1 comma 1. Here it should be 1 comma 1, not 3 comma 3. 1 comma 1 does not belongs to R2. Here the mediator is 3. So AC means A comma C means 1 comma 3, 1 comma 1. So for R3, 1 does not belongs to R3, so it is not reflexive. Here 1 comma 3 is there, but 3 comma 1 is not present, so it is not symmetric. 1 comma 3 and 3 comma 3 is there, 1 comma 3 is there, so R is transitive. Okay. Okay, so question number 5. Question number 5 is the following relations are defined on the set of real numbers. One is A related to B if A minus B greater than 0. Okay. Find whether these relations are reflexive, symmetric, or transitive. A belongs to R. Okay, let A belongs to R. A minus A, which is 0, is not greater than 0. So it is not transitive, reflexive. So A comma A does not belongs to R. R1, R2, or so only R. So R is not. R is not reflexive relation. Let A comma B belongs to R. A minus B is greater than 0. Then minus A minus B is greater than 0. A minus B, B minus A is less than 0. So here you have to write one more line. B comma A does not belongs to R. Therefore it is not symmetric, because if A comma B belongs to R, that means that A minus B is greater than 0, because this is how the relation is defined. But B minus A is not greater than 0. This implies that B comma A does not belongs to R. So that is why it is not symmetric. Okay. Now let A comma B belongs to R and B comma C belongs to R. Then A minus B is greater than 0 and B minus C is greater than 0. And A minus B plus B minus C is greater than 0. Then A minus C is greater than 0. And A comma C is belongs to R. So R is transitive. So here A minus B is greater than 0 and B minus C is greater than 0. Because these two are both positive, that is why these two both positive terms add up to again positive 1. Okay, so you can write two positive terms, adding two positive terms, again we get a positive term. Okay. Hello.
Okay.
Question number 6. Check whether the relation R defined on the set A 1, 2, 3, 4, 5, 6 as R equal to A comma B such that A B equal to A plus 1 is reflexive, symmetric, or transitive. It is an NCERT problem, and we have done it before. So because A set is very small, only 6 elements, and R is defined as B equal to A plus 1, then you can write the relation R. I mean, in the tabular form or roster form, that 1 comma 2 and then 2 comma 3, 3 comma 4, 4 comma 5 and 5 comma 6, these are the elements of R. And for any element A belongs to capital A comma A is not in R, so that means it is not reflexive. And also B, A comma B belongs to R. That means what? A comma B belongs to R means A plus 1 equal to B. That does not imply that B plus 1 equal to A, right? So B comma A is not in the set, and it is not transitive also. So you have done question number 11. Question number 11: is it true that every relation which is symmetric and transitive is also reflexive? Give reasons. Okay. Which problem is this? Which problem is this? What is this number? Problem number what it is?
11 number.
So 11 number
No,
is
no, not 11 number. Uh,
which one?
sorry. This is 5 numbers, 2 number.
Okay, 5. Okay, so 5 2. So A related to B if and only if A plus 1 plus A into B is greater than 0. So let A belongs to R. 1 plus A into A, 1 plus A square, which is greater than 0 for all A, because A square is greater than equal to 0 and 1 plus A square is greater than 1, always equal to 1. So it is greater than 0. So that means, so where is the remaining part? Let A comma B belongs to R. 1 plus AB belongs greater than 0, and this implies 1 plus BA is greater than 0, and B comma A belongs to R. It is symmetric. You have to write this implies sign. So it is symmetric. Let 1 comma A comma B belongs to R and B comma C belongs to R. 1 plus AB and 1 plus BC is greater than 0, but 1 plus AC is not greater than 0. How? What is the basis for this conclusion? 1 plus AC is not greater than 0. What is the basis? How you wrote this?
Because if A minus B,
A minus B?
no, in this, if 1 plus AB is greater than 0 and 1 plus BA is greater than 0, so AB equals to BA. So if 1 plus AB is greater than 0, then 1 plus BA is also greater than 0.
So that was symmetric part. I am talking about the transitive part. How you conclude this statement? This
This is one property.
which property? So if you using some property, you have to write this beside. So what have you used? Tell me. Which property?
This is the property. 1 plus AB greater than 0, 1 plus BC greater than 0, then 1 plus AC greater than, not greater than 0.
Mm, 1 plus AB is greater than 0, 1 plus BC is greater than 0, but 1 plus AC is not greater than 0. This is there is an example. Okay, so 1 plus 1 by 3 into 1 by 2, this is greater than 0. 1 plus 1 by 2 into 1 by 4, this is greater than 0, and 1 plus 1 by 3 into 1 by 4, this is greater than 0. So this is not true. What property you have used? I don't know about any property like this. 1 plus AB greater than 0, 1 plus BC greater than 0, but 1 plus AC is not greater than 0. That means less than equal to 0. 1 plus AB is greater than 0. That means AB is greater than minus 1. That means A is greater than minus 1 by B. And obviously again 1 plus BC is greater than 0. That means C is BC is greater than minus 1. C is greater than minus 1 by B. Okay, so A plus C. Okay, multiplying AC, multiply AC. AC is greater than minus minus plus 1 by B square. So B can be 0. B can be 0. If B is 0, then it is 1 by 0. Okay. Okay. So if B equal to 0, we are taking two cases. If B equal to 0, that means A comma 0 and 0 comma C. So this means A into 0, which is greater than 0, and again 0 into C, which is greater than 0. So in the both cases, these two are satisfying, and 1 plus AC, it is greater than 0. No. If C is negative and less than 0, then it will not satisfy. Okay, so in general, if we try to prove that 1 plus AC is greater than 0, then it will be false. So we have to take an example. Okay, so in general, it is not true. So we have to take an example. So set A equal to 1 and B equal to 0 and C equal to minus 1. Then 1 plus AB, this is equal to 1 plus 1 into 0 is 1 and it is greater than 0. So A comma B belongs to R, and 1 plus BC, that means which is 1 plus BC, which is again 1 plus 0, that is equal to 1, which is greater than 0, but 1 plus AC, which is equal to 1 plus minus 1 into 1, this is plus 1, this is minus 1, so this is equal to 0, but 0 is not greater than 0. So that means 1 comma 0 belongs to R and 0 comma minus 1 belongs to R, but 1 comma minus 1 does not belongs to R. So that means it is not transitive. So in general, this is not true. If we take, I have already shown that for some A and B and C, 1 plus AB greater than 0 and 1 plus BC greater than 0 is implying that 1 plus AC is greater than 0. But it is the example where 1 comma 0 and 0 comma minus 1 belongs to R, but 1 comma minus 1 does not belongs to R. So for by this example we are concluding that R is not transitive. Question number 3. A related to B if and only if mod A is less than equal to B. Here it is mod A is less than equal to B. So mod A is less than equal to A. So R is reflexive. This is wrong. Here it is clearly given that A is less than equal to B. Equal to sign is there. If mod A is less than equal to B and mod B is not less than equal to A, for all AB belongs to A. Mod A is less than equal to B, then mod B is not less than equal to A. Mod B is greater than A. There is some AB. It is not true for every element. If it is true for every element, then you have to prove. If it is not, then you have to give some example. This is mod 2. Okay, mod minus 2. This is less than 4. Okay, we are taking 1. No, this will not work. Mm, okay, 4. Then mod 4 is greater than minus 2. This is A and this is B. No, we want to show that some B is less than A. Okay, is there any example? Mm, mod A is greater than B. Sorry, mod A is less than B. Okay, mod A is always positive. Mod A is always positive. Mod A is always positive, and hence it is B is greater than equal to 0. And B is greater than equal to 0 means B is positive, then B is always greater than A already. Okay, so this is correct. Next, transitive. Let A comma B belongs to R and B comma C belongs to R. That means mod A is less than equal to B and mod B is less than equal to A. Then multiplying. No, this is not correct. So here it is mod A into mod B, and in the right hand side it is less than equal to B into C. This is B into C. B multiplied by C. This is, I mean, this is not correct. This is not correct because no. So this process is not correct. So mod A is less than equal to B, and we know that mod A is already greater than equal to 0. So B is greater than equal to 0. So we have to prove that mod A is less than equal to C. We have to prove this. Okay. So mod A. Okay. 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 So from this line uh, to this line, how you can write this? Why you have wrote this? Tell me. Why you have cancelled mod B and the left hand side there was mod B and the right hand side there was B only. So why you have cancelled these two? One is mod B and one another is only B. So how you cancelled these two?
Mod mod be less than A. This one, no?
No, this is mod A. So one side is mod A and one side is C. If you multiply these two by here it is mod B and here it is B, then maybe this less than equal to sign change to greater than equal to. But why it remains less than equal to? Why? Why it is not changing greater than equal to? Why it remains less than
Because
equal?
only B gets cancelled, so the sign won't
No,
change.
if you multiply these two, then mod A into mod B, and the right hand side is B into C. So how you can cancel one side mod B and another side only B? So you are multiplying. Okay, let us take. You are cancelling this. So in the reverse order, if we multiply mod A into mod B, and here only B, it may reverse the sign. Or how can you cancel these two? In the previous case,
It can't reverse because already mod A is there. So
no, I am
because
cancelling the
of the
mod
mod,
to
this
mod B. I am cancelling the mod B. You have cancelled the mod B. So B, because of B, it may reverse the inequality sign. There is no involvement of A and C. It is because B. You didn't notice. You didn't notice that B is greater than equal to 0. Because whenever mod A is less than equal to B, and mod A always greater than equal to 0. That means B is greater than equal to 0. So mod B is basically equal to B. So that is why you can cancel mod B and B. So you have to write here another line, mod A into B is less than BC, because mod A is, because as A mod A is greater than equal to B, so so B is greater than equal to, which is mod A is greater than equal to 0, that means B is greater than equal to 0. Okay,
Okay.
so this is transitive. Question number 6. Okay, this is B plus 1, B equal to A plus 1. So once in the previous class you have done it, writing the R, the relation in roster form 1 comma 2, 2 comma 3, and now you have done this. This is okay. A not equal to A plus 1, 1 plus A, and R is not symmetric, reflexive, sorry. R is not symmetric. 1 comma 2 and 2 comma 3 belongs to R. 3 equal to 2 plus 1. 2 plus 1 is correct, but 3 is not equal to 1 plus 1, so R is not transitive. So it will be better if you write in roster form the relation R. So this is 1 comma 2, this is 1 comma 3, sorry, 2 comma 3, this is 3 comma 4, and so on. And you will use the definitions. R equal to A comma B such that A is less than equal to B cube. Since 1 comma 1 by 2 and 1 by 2 is in R, and 1 by 2 is greater than 1 by 2 whole cube, 1 by 8, so R is not reflexive. Now 1 comma 2 belongs to R, but 2 comma 1 does not belongs to R, so this is also not symmetric. And what about transitiveness? It is not also transitive, because we will give some example. This is very crucial example. We have done this before. So A is equal to, suppose, 7. So A is less than B cube and B is less than C cube. Then we have to show A is greater than B, sorry, A is greater than C cube. So okay, take A equal to 10 and B equal to, okay, 3 and C equal to 2. So 10 is less than B cube means 27, which is 3 cube, and 3 is less than 2 cube, which is equal to 8, but 10 is greater than 2 cube, which is 8. So for this relation 10 comma 3 belongs to R and 3 comma 2 belongs to R, but 10 comma 2 does not belongs to R. That means it is not reflexive. R is not reflexive. Question number 10 at 12. Wait, where is question number 11? This is question number 11. Amen. What is question number 11? I think we have done question number 10 also. So where is question number 11? Question number 11. So we have done question number 12. An integer m is said to be related to another integer n if m is a multiple of n. Check if the relation is symmetric, reflexive or transitive. Okay. Okay, so what you have done for question number 11? So is it true that every relation which is symmetric and transitive is also reflexive? Is it true or false? True or false? Hello?
False.
False. Because suppose take a equal to 1, 2, 3, 4 and r is equal to 1, comma 2, 2, comma 1 and 1, comma 1. This is symmetric because 1, comma 2 is there and 2, comma 1 is there, and also transitive because 1, comma 1 is there, but it is not reflexive because 1, comma 1 is there but 2, comma 2, 3, comma 3 and 4, 4, comma 4 is not there. So it is not true, it is false that every relation which is symmetric and transitive is also reflexive. Question number 12. An integer m is said to be related to another integer n if m is a multiple of n. Check it is symmetric, reflexive or transitive. So m comma n, if such that m n equal to a belongs to z, so it is told that m n belongs to z. Okay, an integer. Okay, m equal to a n, where a belongs to not natural number. A is also belongs to z. So how you define like this -6? If m equal to -6 and n equal to 2, then this a is -3, which is not a natural number, which is belongs to z. This a should belongs to z also. M equal to a into m is for a equal to 1. That implies m comma m belongs to r, and thus r is reflexive. Okay, for any n or for all n you have to write this. Let us check. This is also true, but you have to write. So for all m belongs to z, m is equal to 1 into m. It will be more precise if you write this. M is equal to 1 into m for all m belongs to z. That implies m comma m belongs to r, and hence r is a reflexive relation. Okay, this is done. Okay, now m equal to an, so n equal to 1 by a into m. So that means R is not symmetric. And why 1 by a is equal to, I mean 1 by a, n equal to 1 by a into m, and that implies n comma n, m does not belong to R. A belongs to Z, that implies 1 by A does not belongs to Z, and this is plus minus 1, and 0 not for, also not for 0. Okay, so A belongs to Z, and Z minus plus minus 1 comma 0, that implies 1 by A does not belongs to Z. So n equal to not some multiple of m, that is why n comma m does not belongs to R. And if m equal to an, a belongs to Z, if, okay, so if a equal to 1 or minus 1 or 0, then sorry, not 0, 1 and minus 1, then this relation is true. So that means there is an element for which this relation is not true. This is in general not true. So you have to write, you have to give an example for this being not symmetric. So this is not correct. This is not correct for all n and m, right? So for some n and, so for some n and m, this m comma n is belongs to R, and n comma m both belongs to R. So you have to give some example. Give one example, which is 2 comma 6 comma 2 belongs to R, but 2 comma 6 does not belongs to R, because 1 comma 1 belongs to R, and also 1 comma 1 belongs to R. This is something reflexive type. So take 1 comma minus 1 belongs to R, and therefore also 1 comma minus 1 comma 1 belongs to R, and minus 1 comma minus 1, okay, this is also reflexive one. So for this example, 1 comma minus 1, this relation R is symmetric, but for 6 comma 2, R is not symmetric. So you have to give this counter example. Okay, got it?
Yes.
Now transitive. Okay, where is transitiveness? You cannot do. I mean, okay. So for transitiveness, let us take m equal to, and you should write nq. This is the quotient. That means m comma n belongs to R, and n comma p belongs to R. That implies m equal to nq, and also n equal to pr. That implies m equal to prq, and this is p. So that implies Okay, RQ into P. So that means M comma P belongs to R, and that implies R is a transitive relation. Okay, okay.
Okay.
Question number 13. Show that relation greater than equal to on the set R of all real numbers is reflexive and transitive but not symmetric. This is actually this is a sorry this greater than equal to relation is actually a antisymmetric relation. You can easily show because how this is antisymmetric. Suppose A comma B belongs to R and also let B comma A belongs to R. So what is happening? A is greater than equal to B, and also B is greater than equal to A. From these two, we can conclude that A equal to B, and this was the definition of antisymmetric relation. So greater than equal to is an antisymmetric relation, and also less than equal to is same antisymmetric relation. Okay, okay. So it is we have to show that it is R is such that A comma B is equal to A greater than equal to B. So let A be element of R. Why are you writing this in words? There is symbols. A belongs to R, and this is real number R. So different use you have to use different notation for the real numbers R. So A belongs to R. A is equal to A. So A is greater than equal to A is true for all A. You should write here all A belongs to R. So A comma A belongs to relation R. That means R is reflexive. A comma B belongs to R. That means A is greater than B is same as B is less than equal to A, but not okay. But okay. So here you can write A comma B belongs to R. That implies A is greater than equal to B. This implies B is less than A. That implies sorry le, sorry. This implies B is not greater than A. B is not greater than A. Okay. So this implies B comma A does not belongs to R, and hence it is not symmetric. Okay. Let A comma B and B comma C belongs to R. That means A is greater than equal to B and B is greater than equal to C. So that implies A is greater than equal to C. So this is A comma C belongs to R. This is transitive. Next 17. Okay, 15, 16. Where is 14, 15, 16? Okay, this is exam NCERT problem. Question number 14 is a NCERT problem. So do this question number 14, question number 18, 11 again. Okay, and send it to me. Then question number 15. Where is question number 15 and 16?
15, 16 also I did last time only.
You did last time.
You check also.
Okay, question number 17 is from NCERT exemplar. Question number 17. Question number 17. Let A equal to ABC and the relation R is defined on A is as follows: A comma A, B comma C, and AB. Then write the minimum number of order pairs to be added in R to make it reflexive and transitive. So A, B, C, and A, B. Minimum number of element. Okay. A, B, C is the set. A is the set. A, B, C. R is A, A. R can be reflexive relation only when elements are added to it. And R can be transitive only when element AC is added to it. The minimum number of pairs is required is 3. A comma A, A comma B, A comma B. And why AC is, we have to add AC? Uh, okay, AB is here and BC is here, we have to add AC. Now, okay, 1 second. Okay. It is not said to make it symmetric. So B, B and C, C. B, 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 C, C, C. Okay, right. That's it. Okay. So you will. This was exercise 1.1. Okay. So question number 18, question number 16, question number 15, 14, and 11. So is question number 18 have already done? Is question number 18
Yes,
already?
I'm done.
Okay. Uh, so all questions are done. So exercise 1.1 is finished, right?
Yes.
Okay. So next do 1.2 and I will check it. Okay.
Okay.